So in last class also we talked about ETL. Okay, we talked about ETL. What is ETL? Extract, transform, and load. Okay, so this is a kind of process you apply to any input data or whatever data you collect. So for a visual example, I had given you last time this example which I got from LinkedIn. Okay, so you can see the oranges, like we extract these oranges, right? We extract these oranges, then you transform those oranges, okay, by cutting them and grinding them together, like blending them, and then you transform and load it, okay, load it in form of containers, right? So this is ETL. Now, how it differs from ELT, okay? So extract, then load them together, then you transform, right? How ETLT, you extract, then transform, load, and again transform. Okay, so you can see this is a very good example. Like those drinks, you could convert them into ice cream later, right? So that is again transform. So it depends on your process which one you want to adopt. Okay, ETL or ELT or ETLT, right? So fine. So more you can see whenever you are combining AI with your data science aspects. Okay. So these things you should be knowing, some keywords at least you should be knowing, which will be helpful to you in upcoming semesters. Okay. Or wherever, like there are many massive open online courses which convert data warehouse as a separate course. Okay. So therefore, in this course, the data warehouse you are learning is one of the most important and very nice aspect that you are learning in this first semester itself. Many other they are not learning this one. Okay. Okay, fine. So you'll see like who uses data warehouse. Okay. So you can see that data warehouse is now practically in every industry, whether it is in e-commerce, because in e-commerce anyway you are storing data, the retail purchases, retail exports, import exports, all you have to store in form of data, right? Wherever you have to store in any method of data, any form of data, you need data warehouse. Transportation, of course, transportation like flight timings, which are the busiest flights, everything can be handled using data. Okay, if you remember data visualization slide I have given to you in the previous two classes, I showed you one map and I showed you with chart how two places are connected. When two destinations are connected by a line, that means the air flight is going in between those two destinations. Okay, and you can see through that chart which airplane or which domain or which destination and starting point are the most busiest one, right? So medical, of course, okay, you are storing medical data, right? So for example, like I want to go for an eye test, fine. So I want to change my specs, right? So what I do, if I go to my specs like optical doctor, then what he will do, if I don't have my history, he has that history already. He will search me by name. Okay, has this guy come to me before? Yes, he has come to me before, and how much plus or minus my glasses are. Okay, based on that, he will change again and he will do. So due to data, you can, I am just giving you tiny examples through which you can sense where it is being used and why it is important. Okay. Banking, I don't need to tell you. Banking, it is storing data of every individual who has opened an account there. Social media, yes, they are keeping a track on you, of course, because who has opened account on my Facebook? If I can know who is there in Facebook, won't the Facebook people know that you are on Facebook? Okay, so they will know, right? So government, right? Government, of course, stores data, a bunch of them. Okay. So all of them, however, to make the data flow secure, to make the data flow smooth, they have to manage using data warehouse. Okay, they have to have data warehouse with them. Okay, now I will show you lot of different examples of data warehouse. Okay, different types of data warehouse being used throughout. Okay, and there is a data warehouse by IBM as well. Okay, known as IBM DB2 data warehouse. We'll see many of them. Okay, so you can see analyze and report on this sales performance. Okay, you can create machine learning assisted shopping recommendations, right? I hope many are many are doing that project before. Okay, which are selling the most. Okay, in Amazon, on Amazon you know it better, right? The one thing you purchase, you will start getting recommendations nearby or connecting that domain, right? Suppose I ordered some say chocolates or something, then what it will do, it will start giving me recommendations for similar sweets, right? Similar sweets or delicacies, something like that. Okay. So how I get those? Similarly, YouTube recommendations, right? If I hear one music, you get similar recommendations on YouTube. Okay. So these are some of the ideas here. Fine. Now, what is a database? So we need to understand the definition of a database so that you can better understand what is a database. Okay. So what is a database first of all? Okay. So you can see these are nothing but structured data in rows and columns. Okay. Of course, in RDBMS, many of you might have learned in your school times or school days. At least in ICSE board, they teach database management. Okay. So you might have seen how these are being handled. All are stored in form of rows and columns, right? In Excel files. Yes, in SQL also. Okay. In SQL also. Like I hope many of you might have gone through SQL in their, I don't remember, maybe class 10th ICSE. I think in ICSE class 10th, they covered SQL basics, okay, already, okay, structured query language. And all are about like uh, gaining which columns and editing which rows, all these things, okay. How to handle those files or database, right? So you can see organizations, they use database to store different transactions that happen within an organization. So such are known as transactional databases. Okay. You can see a company sells a good to a customer. The information about the transaction is stored in a database. That's I have seen in very tiny shops here also. Okay. Any shop you go here, they always scan the item. They will have a QR code corresponding to each item, however cost that item is. Even the item is below 10 rupees, even though they scan it, because they want to keep a track whoever is selling that item to, right? And they can know at the end of the month that how many packets are being sold and how many were purchased, so that they can keep a track how many are misused or something like that, right? So therefore, this example I think many of you might have seen, right? Fine. So these are different aspects you are seeing. These are these are different aspects you are seeing here, right? Like all the different types of databases together here. Fine. Now we will go to the definition of a data warehouse. Okay. So these small points I got yesterday, so I had no place to store them, so I stored them in a very tiny font. Okay, I will come to them. So what is a data warehouse? Data warehouse, you can see. So as she pointed out, gather data, integrate, okay, but you forgot one more word, that is analysis. Then that is the one of the most important one, okay, because in data warehouse, analysis is possible, right? So, but in data warehouse, you will have many input sources. That's one of the most important aspects, okay? In data warehouse, you will have lot of input sources. You can see multiple databases will be there and many input sources. Okay, there will be many input sources. And it stores structured data. Okay, it stores structured data. Fine. Through ETL process like extract, transform, and load, it will use the structured data, right? However, this data warehouse is complex to change. That is the upstream and downstream effects must be considered. Now, what do I mean by upstream and downstream? That's what I have written in tiny bunch here. Maybe what I will do is, yeah, I will make it bigger for you. Okay. And move it maybe here so that it can be visible a bit. Yeah. So upstream is nothing but, upstream is nothing but the data sources that are fed into the data warehouse. Okay. So you can see downstream is nothing but systems that use the warehouse data. So you can see them as a forward and backward direction kind of analogy, right? So it is upstream and downstream. But if you change the upstream, the way you upload the data, then you have to change some rows or change some columns. Okay. If you do that, then it is a bit a bad practice for a data warehouse. Okay. I mean, it is a bit complex to change. I mean, keep things as it is. That's the way for a data warehouse. It is complex to change. It doesn't like change. Data warehouse doesn't like change. Okay. So you can see here downstream systems that use data warehouse data or reports or for analytical tools. Okay, that is downstream. Don't worry about this last sentence. If the warehouse schema changes, downstream analytics can fail. So what do I mean by this term, that is warehouse schema? Okay, that will be clear towards the end. There are two types of schema you will learn. That is star schema, okay, and snowflake, okay. So these are the two different types of schema we will learn in this course, okay. So depending if you change the schema, I mean because of your data set changes, or if you want to add some more data to it, to the previous data set, okay, then what will happen is you have to change, you might have to change. I don't mean that you have to change, you might have to. Okay, if you change the schema, like suppose you made it from star to snowflake schema, then there are chances that your downstream analytical processes might fail. What are the downstream analytical processes? You can see considering these reports or analytical tools here. Okay, maybe visualization tools. Okay, you will see that one aspect of data warehouse is visualization. I have till now I have not shown you the structure of data warehouse. Okay, but the structure of inside the data warehouse there is something known as a data visualization column. Okay, where data visualization happens. Okay, if at the end you are changing your data sets or the schema, then your analytical tools might change. The way you want to visualize things might change, right? Are you understanding the idea? You can think of it as in Python, right? See, like if you are adding one more row, suppose you are adding one more row, but in your previous data set, we already know that these are the amount of rows, these are the number of rows, and depending on that, you are printing it like a scatter plot or something like that. Now, after that, if I add one more row, okay, if I add one more row, the size or the shape has changed. The shape of the data set has changed, right? You have to let the coding platform know that the shape has changed, right? So until you do that, it will fail. Okay. So that means some manual troubleshooting will be needed after you change your schema. Okay. So therefore, data warehouse is very, I mean, it is risky if you want to change anything in between. So once you feed it, you feed it. Okay. Fine. So data warehouse comes with some size, like you can see it is greater than 100 GB in size. Usually it is more than 100 GB in size. Okay. So you can see here even it is written in a very nice way. Once a data warehouse is built, okay, changing its structure, that means schema, that is star or snowflake, or the tables or the relationships between the columns and the rows, it can be difficult. Once a data warehouse is built, if you change its structure again in between, it is difficult. Okay, it is difficult, right? It's one of the most important point to keep in mind, because when you will be dealing with data warehouses in your real world projects, there you will know or understand it more clearly than now, because now you're understanding from a theoretical perspective. But the moment, I mean, when you go for interviews and all, they will ask you what is a data mart, how in data warehouse where data is stored, okay, how what is a data lake, how it is differing from a data mart, okay, and how what kind of analytical processes a data warehouse can do, okay? Because once you go into their job or position there, they will be using some kind of data warehouse inside their organization. So So you can see like this is because many reports or dashboards or your dependent systems or columns, they rely heavily on the schema. Okay. So just hold on to it. What is schema? Okay. Schema, just understand that schema is nothing but a structure. How you are storing the data. Like maybe I have to see, this is suppose this is me suppose. Okay. This is how I manage data. What I do, I collect data from your course. Okay, I collect data from your course. I collect data from some of other courses. Okay. Uh, and then I collect them together and make it into an Excel file. So I store my data and all processes using a star schema. Okay. So now I heavily depend on this star schema, right? Now, if suddenly in between they assign me something else, like for this numerical methods, maybe you create another assessment report or something like that. Okay, but it is a part of that course. So then it will turn out to be a snowflake schema instead of a star schema, right? Then it will affect me. Then I have to change all my processes. Okay, how I will get hold of this assessment report, it's a bit difficult because since it is new, I might not have a direct connection to it. I have to go through this via media to connect to it. Okay, so these are some of the notations why changing the schema can create trouble. Okay, so whichever schema is being used from the start should be used. So therefore changes require careful impact analysis. Okay, changes require careful analysis. Okay, you may ignore the word impact. Okay, but changes require careful analysis. So therefore, in data warehouse, the minimal change you do, the better it is. Fine. So why we need the data warehouse? Okay. So you can see, data warehouse is very nice because many operational systems you can perform. What is OLTP? OLTP is nothing but OLTP. Anyone knows about OLTP? Hmm? I can tell you the first word online. Okay. Then the other three words is up to you to find. Okay. P, I can tell you the process. Okay. Yeah. Yeah. So you should tell me next. Hmm? Hmm. Okay. Okay. So you can see like ordinary database systems are not designed for analysis or decision making, right? So this is one of the reason we need data warehouse, because in data warehouse you can consider these analysis inside the data warehouse. Okay. Therefore, usually any organization you take, those who are handling lot of data, they should be having a data warehouse. Okay, now you might have a question. Suppose I run an organization, I am running an organization right now, then what kind of a data warehouse system I can use? Okay, is something like nothing but it's like Google Docs, right? It's like Google Docs, or say like any other software system like Libre, right? If you are using Linux, you can use Libre, right? How many of you are using Linux? You are using Libre, LibreOffice sometimes. So LibreOffice is very similar to Excel, I think, right? Excel and Word, all this file, they are similar, right? So that's it. That's it. So you have to get a data warehouse or purchase a data warehouse given by the vendors. Given by the vendors. Okay. So what kind of data warehouse? Some data warehouse can be in your institution or organization. Some data warehouse can be given by Azure, like Amazon Web Services. Okay, those are online. Then you say how much GB of data you need. Okay, suppose if for this class I want a data warehouse, 100 students, hardly everyone data will be minimum of hardly 1 MB, right? 1 MB data, so 100 MB. So I have to just purchase maximum 200 MB data from them, right? So the data capability, I will select, I will click the button 200 MB, okay, and I will select what's the RAM I need, what's the other, what do you call that? I forgot that catchy term. Specifications, right? What are the specifications you need, and depending on that you purchase it. Okay, so that's I have seen personally for Amazon. Okay, suppose I will give you very nice, I think I gave this example last class, isn't it? How from Amazon you can purchase a number of cores or something. No. Okay, suppose you are doing some projects. So I will give you a very interesting example. through which you can understand that similar thing works for data warehouse. Okay, suppose you are using your laptop. How many cores the laptop has? Hardly 6 or 8 cores. Hardly 6 cores. Okay, if 12 cores. Suppose 12 cores. Okay, your lab systems have, in the first floor they have 12 cores. Okay, I mean that's it. Okay, any additional cores you want to have, you have to purchase and install it. Right? Why we need the number of cores? That's the first question. Now, if suppose I will give an example, like suppose biologist, they need to scan lot of gene combinations, isn't it? Which gene combinations or something can lock or protein folding, whatever. These are very computationally expensive processes, right? Protein folding and all those things. So which combination, which bond and all, which configuration of a bond can help me make one compound or a vaccine or something like that, right? So how you will do that? There are so many combinations. Okay, there are so many combinations. So therefore, it will need a lot of heavy tries. It will need at least a lot of tries, around 10,000 or 1 lakh tries or 1 lakh iterations, right? How are you going to do 1 lakh iteration in your normal laptop? How are you going to do 1 lakh iterations in your normal laptop? That's my question to you. Your laptop will get heated up, right? And it will slow down also, right? So what is the option to, what's the option? If you are lucky, your institution might have a cluster computing, cluster access, where you can submit the jobs and run in various cores. Suppose you don't have, then due to this issue, Amazon on his online platform has revealed that you can purchase from them. Okay, so for this project, for next 20 days, I want to work on this project, right? Suppose protein folding project I want to work. So for the next 20 days, what I will do, I will rent it. Okay, from Amazon website, I will just select how many cores I need. Okay, how many additional cores I need? Okay, 300 additional cores. 300 cores I need, 300 cores you type. Okay, how much days you need? Okay, 20 days. 20 days, okay, 20 days you type. Okay, then you do and generate the bill. The bill will be generated. Yeah, depending on your specification, your amount is some $30-40, right? Based on that, you pay it and use it. A username and a password will be given to you. You can always connect that system to your local machine and run all of your code and everything on that online platform, which has all the cores, 300 cores, and your all codes can work in parallel, right? And you generate the output, which was not possible in your laptop. Now you could generate it within a few hours or a few days. So are you able to understand what I'm trying to say, right? So that is the case of online data warehouse. Like if you want to take one data warehouse only in online mode, you can purchase it in online mode. Now there are some data warehouse which are available both in physical as well as online. I mean, physical organization, you can have data warehouse. After you take a leave from the institution and are away at home, there also you can work with that data warehouse because it is available online as well, right? So these are some of the ideas. You can see the same thing. Running queries involve a large amount of data, okay, which could take a very long time, okay, possibly slowing down the database and restricting it from its primary purpose of recording transactions. So this is the reason why databases won't serve the purpose alone. This is the reason why we have to move further away from the database. Okay, the further away from database is nothing but data warehouse. This is the reason why data warehouse is being constructed. Okay, fine. So this is some ideas. Okay, yes, as I was telling you before. Okay, as I was telling you before, like there are different types of data warehouse systems you can categorize. One is appliance based, okay. One is only online medium, that is cloud only platforms on premises, right? So on premises is something like, let us go one by one. So you can see appliances, okay. So these are pre-integrated bundles. So don't worry about this sharp keywords like bundles or pre-integrated those things. So those are more towards computer science technical terms. Just understand the, I mean, intuitive things from it. Okay. So bundles of hardware and software that provides high performance for workloads and low maintenance overhead. Okay. Fine. Then cloud only. So you can see only it will be available on cloud, like online medium, right? So you can see that has a benefit. Why that has a benefit? It doesn't demand any physical space. Okay, it doesn't demand any physical space, right? Do you agree? See, now we have to spend one full block around here. You can see after that network room, we have to spend one area. Inside that area, full clusters are there. Okay, and always we have to keep the temperature low. So we are spending a lot of amount of money to cool it down, because many people are using the clusters and the computers or systems, they get heated. Therefore, at 24 hours we have to cool it down. Okay. So even when you are using GPT and all in US and all, they are all using cooling systems to cool down. Okay, we are generating a lot of images and there it is getting heated up, right? So it demands maintenance. Okay, this is why where you hear this word low maintenance. Okay. What do you mean by maintenance? But if your system is in cloud, now is the age of cloud, to be honest. Okay, now is the age of cloud. Everything you can do on cloud, and we are trying to move everything into clouds. Okay, cloud systems, right? So you can see one benefit is scalability. How much you can scale it, right? For example, I forgot, but I forgot the name. It had an icon like this, something like this, and forgot. I forgot. It had like it was asking me how much I was using it before. I am not using it now, but it was very useful to me. Like I was very having very little amount of data in my Google Drive. Okay, always my Google Drive was getting full. So what I did, I purchased this platform. I forgot, OneDrive maybe. OneDrive. I forgot some similar name. So in OneDrive, I can upload. If I buy some space, I can always upload my data and always share it with other people. I don't have to always attach my files. I will just give a link of my file and just say like you see these 10 PDF. Okay, I don't have to personally attach those 10 PDFs. Those are there in my OneDrive file. I have to just generate a link from there, give access to that person. Okay, or give access to anyone who has the domain name @duk.ac.in. They can always access it. Okay, so that's how scalable it is. If your systems are on cloud, it is scalable. Okay. Premises, that means it is in your institution or organization, software installed only within on-premises environments, right? Now, these are the ideas. So I will be, next slide, so I'll be giving you examples of many different data warehouse. Okay. So might be helpful to have a practical understanding. I mean, how they are constructing these data warehouses. Okay. So you can see Oracle. I hope everyone knows about Oracle, right? So Oracle Exadata is one of the data warehouse. Okay. So you can see it is deployable both on premises and also on cloud. So it is available both on premises on the organization as well as on the cloud mode, right? And this data warehouse, this is a data warehouse created by Oracle, okay, known as Oracle Exadata. Okay, and you can see this data warehouse has a lot of built-in algorithms, right? This data warehouse has a lot of built-in algorithms inside it to perform all types of analytical processes, right? And it can run all types of workloads, all types of workloads. Okay? So a few slides I'll be giving you, will be hearing a lot of names. Okay. So this is by IBM, known as IBM Netezza, right? So you can see this is deploys on IBM Cloud, Amazon Web Services, okay, and Microsoft Azure, right? So you can see deploys also private clouds using IBM Cloud Park for data system. I mean, these are all his IBM Inside related things. And one good thing about it is it has all these data science related tools and ML tools inside it. So it can perform many different analytical tools easily. Right. Another, yeah. Another is something like only cloud. Only cloud. In your premises you won't have it. It is available only on cloud. Is something like Amazon Redshift, right? So you can see AWS uses this specific hardware and proprietary software system for this. One good thing about it is your data are getting secured. How? Using data compression, okay, and also using encryption. This ensures that data privacy. This ensures data privacy. I don't know if I have told in this class or it did not come to picture now. I think I remember I told in this class that the more one important part of data is to store data, how we store data and how we process data. But another most important aspect is how to destroy data when needed. Okay, one of the most important aspect is how to get rid of data when needed. Suppose suppose some attack, cyber attack has happened to a particular institution, and the institution has lot of private data of many students, right? All of your information are on that website and all database management system. Now if that gets hacked or something like that, then how we can at least delete the data or secure the data and then delete from our system within that small amount of time. You will have that small golden window. Within that golden window only you have to do all this process. If you move out of that window, it's gone. Okay, if you move out of that window, it's gone, right? Fine. So many different algorithms you can see. These are like optimization algorithms that automatically organize and store data. So this is where I want to show you the power of optimization here also. Like maybe in your coming semesters, you might have some courses, not everyone, but this is where I ask that how optimization are useful, right? Hmm? How optimization algorithms are useful. For example, like in your ML algorithms, uh, you have not gone through any course right now, no? Not started in this semester, right? Maybe in your next semesters, when you are learning about predictive or something like that, you will be coming to know about Optimizer. Adam Optimizer. So this is the optimizer, all deep learning and machine learning tools they use, okay, in any of your coding part. Okay, any coding you do, maybe extracting images or anything else, you will be hearing this Adam Optimizer. You will be always importing Adam Optimizer. Okay, using that Adam Optimizer as it is. Okay, but how Adam Optimizer is working? What is the inside working of it? Okay, as you will see, Adam Optimizer has two wings. Okay, uh, I will not go into details, but it has two wings and very nice gradient descent algorithm it uses to optimize things inside it. Okay. So therefore, I am giving you a overview of why and how optimization algorithms are useful to organize and store data. Okay, and how graph. Are you able to understand? A very nice line here. Are you able to understand the idea between graph and organize and store data? Are you able to connect the two together? Are you able to connect graph and this line? What is a graph basically? Graph, I will tell you a very nice example. Okay. Um, yeah, maybe we'll take him. Okay. So he is there. Maybe he is here. Okay. He is here. But his friends are there. Okay. His friends are there. Okay. So now also he might be connected to them, right? He is connected to them, right? So this is one of the graphs, right? This is one of the graphs, right? So everyone is connected to everyone. Okay, all of your friends are connected to everyone, but some of you don't connect with each other because you are not that much free now, right? Or have communicated before. So that's what is a graph. Okay, in a social circle, just like Facebook or Instagram or any other WhatsApp, right? Whom you have connected to. We can make a social network, right? You must be taking social network any elective now? No, you're not taking. Fine. So this is how you can see based on this, maybe I can categorize where they are and I can store them at appropriate places. So how graph and organize and storing data are linked. That's one of the most, very nice ideology between them. Okay. Another cloud only offering is Snowflake. Okay. Another name. You can see it is very flexible. It offers multi-cloud analytics solution. Okay, data privacy. So due to this aspect, mostly data warehouse, these two data warehouse will be preferred. Okay, because other data warehouse don't give that much importance to the data privacy part. Okay, however, these two you can see because Amazon Redshift is focusing on encryption and Snowflake is focusing on data privacy compliance. Due to these two data warehouse, they focus on data privacy a bit more. So this is one of the reason why people might prefer these two data warehouse as compared to others, because data privacy is one of the most important in this age now, right? These I will not go into detail. These are technical. I mean, just for your knowledge, if you want to explore more about this, you can explore. Okay, I will not go into detail. Okay. And one of the most important things, so many people will prefer Snowflake data warehouse. Why? Because he is giving more preference to the data privacy, high preference to data privacy, right? Because you can see always on encryption of data in transit and at rest period. Always it is trying to focus more on the data privacy. Okay. But however, you can see that a lot of ML tools and all might not be used in this data warehouse. But of course, it is providing you some analytics as well. So what else you need? It is providing you some analytics. It is providing you high level of data privacy. So due to this, many people will prefer, many organization might prefer the Snowflake data warehouse, right? So you can see it's a good one. Okay, fine. So another is something like Google BigQuery. Okay, it is multi-cloud, it is flexible multi-cloud data warehouse solution. Reported uptime of 99.99%. I mean, whatever you upload easily gets uploaded. No lag is there. Fine. And mostly might be used for business tools, BI, like business intelligence tools. Okay. Fine. And you can see how heavy data it is able to store. Okay, you can see what's the size of it, petabyte. Okay, petabyte. I think I don't know. Recently, someone downloaded the whole of YouTube. Someone downloaded the whole of YouTube. Have you heard that news? No. Hmm? Heard that news? Okay. And it can also give you real-time analytics. Okay, it can also give you real-time analytics with high availability and also this concurrency. Fine. So these are some of the ideas where you can use data warehouse. Okay, which type should you use depends on your organization and I mean the plan which you have for your organization to work on. Okay. Fine. So this is another one where you can see both on-premises and cloud services are there, right? On-premises, both you can find them on premises as well as on cloud. Is something known as Microsoft Azure. Okay. I think this is, you can Google this Microsoft Azure, okay, to know more about them. Okay. So you can see it is works with either ETL or ELT processes to easily ingest data or integrate data for more than 95 native connectors. So you can see when I told you the data warehouse will take data from multiple data sources. This is what I mean. Okay, this is what I mean when I tell you that in data warehouse, we take data from multiple sources, right? You can see how it is taking data from 95 native connectors. Okay, so from 95 different, sources, it can take data and connect to its data warehouse. This we will understand. This is something very important. What is a data lake? I don't know. Maybe next class we will cover this. Data lake supports data lake and data warehouse use cases. Supports Python and Spark and SQL.NET. Okay, and other things like I don't know about this Scala or T-SQL, but I have heard about Spark, Python, and SQL.NET. Okay, for both serverless, and dedicated resources. So this Microsoft Azure is also something good, but however, we don't know much about its privacy. Of course, it would be dealing with data privacy, but I don't know. I mean, not one of its good points. Okay, but you have to manage. If your data is already secure somewhere, then you don't worry, have to worry about data privacy in a data warehouse. Okay, then you can worry only about the what kind of analytical processes I can do, what kind of machine learning tools I can use, okay, how many number of native connectors it can use. If you have lot of different subdomains or sub organizations in your main organization, right, and you want to collect data from many different sub organizations to your main organization, then one of the best one is Microsoft Azure, because you can see it is dealing with 95, more than 95 native connectors, right? So from more than different 95 different sources, it can get data, right? Fine. So this is one which I gave an assignment last year to students. Okay, I gave these assignments to students to have a presentation last year. Okay, when this course was a 300 level course. Okay, that means you don't have a project or something like that, right? So people gave very nice talks about this warehouse, IBM DB2. I'm in the batch who has just graduated, like in convocation or something. So they were excitedly presenting this. Okay, I don't know. It's quite good. IBM DB2. So that therefore this data warehouse I vividly remember because I heard from many students. So you can see it is very useful in scalability. Okay, it's very nice for scalability. Petaflop speeds, high speeding approach, like whatever you submit, however data analytical tools it can do very fastly. Okay. However, you can see rich security features. Okay, 99.9 service time, same as your Google BigQuery, right? Fine. Move workloads with minimal or no changes required. This is one of the most important for a data warehouse, right? We understood this. This one is most important, no? We understood why in a data warehouse minimal changes should be done. If you change any columns or rows, then some things can change, right? You have to do more effort or more downtime. Downtime effects might get hampered if you change your shape of your data or something like that, or schema, the dataset schema, right? Fine. Maybe I will leave these two for you, okay, to understand Vertica and Oracle Autonomous Data Warehouse. But you can see many data warehouse focus on many different approaches like threat detection, securing data. Okay, some are working on speed. Okay, some are working on what analytical tools. Okay, analytical tools, right? Analysis. Anything else? What we have seen so far? Yeah, 95 connectors. Okay, I mean, how many connection we can make? Okay, how many connections we can make? Hmm? How many connections we can make, right? How many different sources it can take data, right? So what's the yeah? So I think like we should wrap up this lecture by giving you a definition of data mart and data lake. I think then you can have an overall idea. Okay, so won't take much time, but just 2 slides here. But yeah, these are the two important definitions now in an organization. This I have seen many students were asked in interview. Okay, they asked what is a data mart. Okay, and where you are storing that. I heard 3 questions from data warehouse in a interview. Okay, one is where you store data in data warehouse. Second, okay, second is what is a data mart? Okay, how why data mart is needed especially. Which one would you prefer for a specific application? They gave a specific application to them. Like suppose we are doing this. Which one will you prefer, data mart or data lake? Okay, these are the 3 questions I could take out from students who appeared for different interviews. Anyway. So we'll see what is a data mart. Okay, so it's a kind of a relational database, but how it is different from a relational database? Because it is used for analysis. You can perform analysis in that, right? So you can see data marts is something very nice. Why? Because it focuses on only one subject area. It focuses on only one subject area. Say finance. Okay. Suppose he wants to focus on finance. Then which one he will take? He will take data mart. Okay. He will take data mart, right? So one of the important things is it holds structured data. Remember this carefully. A data mart holds structured data, right? So it will hold structured data for you. However, one of the differentiating aspects or contrasting aspect is few input data sources. Okay, you can have very few input data sources. I mean, the number of connectors, you cannot discuss many of them and collect them together into your data warehouse. In data mart, you can have only few connections, right? And it is less than 100 GB in size, less than 100 GB in size, right? Fine. Now you can see, now let us go to data lake. Okay, you will come to see how these are different from a data mart, right? So what happens in a data lake? You can see it is different. In a data mart, you can have less number of connections, isn't it? Whereas in data lake, you have more number of connections. I mean, more number of different connections can integrate into a single data mart, data lake, right? So that means indirectly, it means it has many input sources. It has many input sources, isn't it? Most importantly, it has greater than 100 GB in size. Now, how it is different from the data mart? It has less than 100 GB in size, right? Remember that in data mart, you were storing only structured data. Whereas in data lake, you are storing both structured and unstructured data. Okay. In data lake, you are storing both structured and unstructured data. For example, you can have these audio, video, and as well as Excel files or database files, right? So this is one of the important difference. Okay. Why you do that? Why you store every different format of data might not be clear now, but can be seen useful in further future analysis, right? This is the box. This is the box where you can see the different differences between a data warehouse, data mart, and a data lake, right? You can see data warehouse stores structured, whereas data mart also structured, whereas data lake is a more general aspect. That is, it stores both structured and unstructured data sets, right? Yeah. If you complexity to change, I mean, if you are doing some change to your data or schema, say star or snowflake schema, right? Data warehouse acts complex. I mean, it is very complex to change something like that in a data warehouse. It is also complex to change something like that in a data mart. But however, it is less complex in case of data lake. Okay. So if your organization always deals with scenario which always leads to the change of the schema, right? Or you always have to edit your data sets or something like that, then which one would you prefer? Data lake. Okay, you won't prefer any data mart or something like that. You would prefer data lake because it is less complex to change. It can absorb the changes you are making, right? Fine. Purpose of data, this is simple. Coverage, yes, coverage of departments in your organization. Maybe data warehouse covers many, we already know. Okay, Snowflake did 92 different nodes, right? Covers many different nodes, right? However, data mart focuses only one of the few, like finance. I will focus only on finance. Okay, or I will focus only on management issues or something like that. Okay, but however, if you want to cover both management, finance, and other things, then you have to go for data lake because it covers many. So if you have a very big organization where you want to store, where you want to cover or integrate many data from many departments, then data lake is the way to go. Okay, fine. Data sources also you can see. Data mart has a few source nodes, whereas data lake has many source nodes. Typical size, data mart has very few, less than 100 GB, whereas data lake is preferably more, like greater than 100 GB, right? So you can see how the competitions are in between the data warehouse, data mart, and data lake. So depending on your organization's application, your organizational needs, you can either prefer data warehouse or data mart or data. Okay. So this is something you should be aware of. Okay. I understand this is a lot of theory. I could have asked you to cover it yourself. Okay. But it is also boring a bit for me also. Yeah. But it is my duty to convey to you. It is my duty to convey to you what are the important aspects of the data warehouse and what is a data mart, what is a data lake. So now you know these keywords. Okay. Now it is not unknown to you. Okay. Anyway, we will look into other things we'll start with this slide in the next class. Okay, what we summarized in today's class, we'll start from here, and yeah, we'll go through it. And next class, if time permits, we will discuss schemas, like what is this different schemas you can see, and what are these approaches. So this is one of the most important aspect as well, like Kimball bottom-up approach. Okay. What is a data warehouse, you will learn. Okay, how, I mean, next class, why it is important is because you will know what are the different layers of a data warehouse, how a data warehouse works. Okay, fine. We will see into different aspects, and this is one of the most nice slide where you can understand how a data warehouse actually works. Okay, how a data warehouse actually works. Okay. Fine, so we'll stop here. Okay. Yeah.